Greetings. I got asked to work through the examples on normal probability examples from the textbook using the calculator. So I'm going to go ahead and do that. I'll work through as many of these as I can get through in a reasonable amount of time. And hopefully that'll bust the dam for you and show you the difference between doing these by the table and doing by the calculator. Generally speaking, we never use tables. We use technology to do these calculations. So tables are in there kind of as a way to show you in case you didn't have a calculator, but we do have one, so we're going to do it that way. All right, so let's get after it. Example 3.9, Shannon is a randomly selected SAT taker. Nothing is known about Shannon's SAT aptitude. What is the probability that Shannon scores at least 1630 on her SATs? Okay, now the book gives you really good advice here. You should always start off with a drawing, all right? That is huge. So let's go ahead and get a whiteboard up here and let's start a drawing. And by the way, before I start that, keep in mind that they've given us that the distribution of SAT scores is modeled by a normal distribution with mean 1500 and standard deviation of 300, okay? So we'll bring that over with us. So we have normal 1500 by 300, okay? That's important, all right? So what that tells us is that the distribution of SAT scores is bell-shaped and the mean is right here at 1500. 1500, there we go. Okay, so mu is equal to 1500 and sigma is going to be equal to 300 for this distribution. All right, now they also told us in here that they want to know what is if she scores at least 1630, okay? So 1630, as you can see from the drawing that they gave us, is roughly about there. And so we want to know what is the probability of x being greater than 1630. Now, they didn't really do a good job of showing you that notation. I think it's a really good idea that you write that down. The reason for that, excuse me, I got a bit of frog in my throat. The reason for that is that notice that this inequality symbol, when I write that notation down, the inequality symbol points to the direction which I need to shade in my distribution. And the thing to keep in mind why I'm doing this is that that area right there that I'm shading right now is that probability. In other words, this brown shaded area here is that probability of x being greater than 1630. And you can think about the inequality symbol as being an arrowhead pointing in the direction in which you need to shade. All right, now from there they say go ahead and calculate the z-score. Now calculating the z-score unto itself is a really valuable thing, and there's no loss in doing that. I mean, let's go ahead and scroll down to what they're doing here. They're asking us to calculate what her z-score is, okay? So if we calculate her z-score, let's just copy down their calculation here. Z is equal to x minus mu divided by sigma. And it turns out that's a really important little formula, because what that gives us is the distance in units of standard deviation that x falls away from the mean. And the larger the z-score is, the farther away x is from the mean, okay? So in our case, the value was what? It's 1630. The mean, the population mean, was given to be 1500. And the population standard deviation was given to be 300. Okay, so if we want to calculate that on our calculator, let's go ahead and get our calculator out here real quick. Give me just a second here. I got to get it where you can see it. All right, so we're going to put that into our calculator. We're going to come in here and go parentheses. Hugely important. Make sure you put a parentheses in the numerator. This little nasty thing right here, this fraction bar, is also a grouping symbol, all right? So that's 1630 minus 1500. And we're going to divide that by 300. If you don't put those parentheses in there, you're not going to get the right answer. Then we get back, what, 0.43. So less than a standard deviation, basically about a half a standard deviation above the mean. So that's not going to be all that unusual, so we'd expect the probability of scoring 1630 or higher to be relatively large, okay? All right, so let's go ahead and do that. Now, I'll go ahead and write the command down here, and then we'll calculate it on the calculator. So we've got the z-score, but we don't necessarily need that to do a normal probability calculation on the calculator. The calculator has a command called normal CDF. And we'll call it norm CDF just to abbreviate here. And what it wants on there is it wants the left-hand value, it wants the right-hand value, it wants to know what the mean is, and it wants to know what the standard deviation is. Okay, so for our particular problem here, the left-hand value is 1630. What about the right-hand value? Well, this goes off to positive infinity. So how do I get out to positive infinity? Well, the calculator's version of positive infinity is 1 times 10 to the 99th power. That's as big a number as the calculator can handle, okay? So as far as the calculator is concerned, that's infinity. So to get to that, we're going to get this times 10 part by using the exponential mode or the engineering mode. And so it turns out to be just E99. That's all you got to type in there, okay? I'll show you how to do that in just a second. All right, so the command would look like, if you don't mind, I'm going to abbreviate to NCDF for normal CDF. Left endpoint is going to be 1630. Right endpoint is going to be E99. The mean is going to be 1500. And the standard deviation is going to be 300. Okay, so now let's go and get the calculator out and let's actually do that. So let's go ahead and get my cursor going here. It's clear. Okay, so where do we find that? It's in the distributions menu, which is a second function above vars. So if I go second distribution, I'll see that normal CDF is option number 2 here. Wants to know my lower number. My lower number was 1630. This is why you do the picture, because once you've done the picture, coming into the calculator is easy. It's just copying that information into the calculator. My upper number was E99. Now, how to get the E99? Well, look above your comma here. You see what it says E? It's got the double E there. So you go second E, and then you go 99. Now, you can put a 1 in front of it if you want to, but it's not necessary. Okay, the mean for this distribution was 1500. Standard deviation for this distribution was 300. Now, if you're an old dog 84 that has not been upgraded, the next command, it says paste, and notice it built it on the home screen for us. If you're an old 84, you may have, when you hit norm CDF, just got normal CDF, came up to the home screen, then you would type in the 1630, comma, E99, comma, 1500, comma, 300, okay? Just like I built when I wrote it down on the whiteboard, okay? Cool, so hit an enter. I'm gonna get about 33% probability, okay? So that she gets roughly about a 33% probability. All right, let's go back over here for just a second. So notice it's way more work if you did it by the tables, because it's a left-hand table, which means you have to subtract that from 1 to get it back to be a right-hand table. Okay, so you got to admit the calculator is a heck of a lot easier. All right, so let's go ahead and do the guided practice real quick, and then we're going to go down and switch to inverse norm and what that is. Okay, so the probability of Shannon scored at least 1600 is 0.3336. What is the probability that she scores less than 1600? Draw the normal curve representing exercise and shade the lower region. Now, we're not going to do that one. That's silly. We don't do that because we don't have to do that because the calculator is easy. All right. So Edward earned a 1400 in his AT. What is his percentile? Okay, notice he scored below the mean. So that means his percentiles, let's talk about percentiles for a minute. Percentiles are the number by which that percentage of the distribution falls above or below that number, particularly below. Almost always we're going to be talking about percentiles, it's below. So in this case, what we want to know is what percentage of the people who took this placement or took this SAT with Edward scored less than 1400. All right, so let's go back over to the whiteboard for a moment here. There we go. All right, let's get a new fresh page here. Okay, still the same distribution. It's still 1500 by 300. But this time, let's see, what did Edward score? He got 1400, right? Okay. All right, so let's draw the distribution here. Again, this is the mean at 1500. And this is sigma equal to 300. All right, and so we know 1400 is roughly about there, and they want to know what is the probability of x being less than 1400. So notice what that means is I'm going to shade down here. I'm shading this region here. Let's get my highlighter. We'll do it that way. Ooh, pretty. Ooh, yeah, look at that. Okay, that's nice camo looking lower section down there. Okay, great. All right, so that region, that area, when we calculate that area, that is going to be the probability of x being less than 1400. Okay, so it'd be n CDF. Okay, now what's the left endpoint this time? Well, it's negative E99. It's negative infinity. So negative infinity is down to the left. To the right is going to be 1400. So it's going to be negative E99 by 1400 by 1500 by 300, okay? And that will give us that green shaded region. All right, so let's go back to the calculator and let's go ahead and type that in. So we're going to go second. Look at the cursor going here. So we can go second, distributions, option number 2 for normal CDF. Our lower bound is negative E99. Our upper bound is 1400. Our mean is 1500. Our standard deviation is 300. We don't need to change those. We'll go in and paste that command to the home screen and an enter. And about 37% or 36.9% of the students scored less than Edward, so he is the 37th percentile is one way of saying that, okay? Now notice the book is going to get slightly different numbers because they're using tables. The calculator is more accurate. They, generally speaking, when you round to 2 places, will always agree, but just in case you get a slightly different answer than what the book is displaying, it's because they're using tables. Don't let that bother you, all right? Okay, let's move on to inverse norm. In other words, if I give you a percentile, how do you tell me the how do you tell me the person's score? Okay, so all right, what adult male height is at the 82nd percentile? Okay, so we've got to back up for just a moment and get the normal distribution of male heights. Okay, so all right, based on men, heights men. Okay, U.S. men is normally distributed with a mean of 70 inches and a standard deviation of 3.3 inches, okay? So they gave us here that the distribution is normal with mean of 70 and a standard deviation of 3.3. Now keep in mind that the measurements here are in inches, so when they give you feet, you've got to change into inches, okay? So let's go work. Let's go get some stuff done here. All right, let's scroll down. All right, so we'll use this to help illustrate how you find a height given a percentile. All right. Okay, so what is the adult male height for the 82nd percentile? So first, we're going to draw a picture. Every one of these problems, draw a picture. Don't get lazy on me. Make a picture every time. All right. So new distribution. It's normal with 70 by 3.3. Make sure you always write down the model first. Then you draw yourself a picture. The mean here is at 70. Standard deviation is equal to 3.3. And again, these are in inches. Probably put little tick marks to remind myself that, okay? All right, so what do they want to know here? So they're asking, what is the adult male height at the 82nd percentile? Okay, so what that means, so come over here, we'll just roughly put it in, is that it's saying that we know this time, we know the area. In other words, we know this green shaded region here. We know the green shaded region is 82% because it was the 82nd percentile. Think about that for a moment. Make sure that makes sense to you, because no sense going any further if that part doesn't make sense, all right? So look, they said they want to know what is the male height at the 82nd percentile. So what that's telling us is that inside of here, this is 82%. And what we don't know is the position on the axis. We don't know what x is equal to. We want to know what that value is. All right, now it turns out that, lucky for us, the calculator's got this built into it. But it's a little bit trickier in that it only sums from the left. So you got to be a little bit careful here. So just to preview coming attractions, stop for a second and tell me what's the area of the red shaded region right here. Think about that for a second and tell me what that red shaded region would be. Did you shout it at me yet? Well, let's see, one way of doing it, I mean, if you're feeling a little wheezy with your arithmetic, is you can come in here and go, okay, well 82% is 0.82, so if I take 1 and I subtract from it 0.82, what's left over is 18%. So this region over here is 18%. Now why? Well, because the whole thing has to add up to 100%. The total area under the curve always has to sum to 100%. So if I want to find that 18%, I can take 100% and subtract from it 82%. Okay, hang on to that. We're going to need that in a few minutes. We won't need it on this one, but we'll need it later on. Okay, so how do I find that position? Well, it turns out that the calculator has a very cool tool built into it. It's called inverse norm. And what inverse norm says, it says if you gave me an area, I'll give you back the position. So I have to input the area as the first thing that goes in, whatever area is under the curve. Then I give it mu, and then I give it sigma. Okay, so in our case, that's going to be what? It's going to be INV norm, and it's going to be 0.82, and it's going to be 70, and it's going to be 3.3. Now, the important thing about that area is that area has to come from the left. It has to be the left shaded region. Okay, make sure you keep that in mind. That's super important, otherwise it won't work. All right, so let's go get it to go here. So we're going to go second distributions again, and notice option number 3 is INV norm. So go to option number 3. The area in here was 0.82. Catch my 8 there, 0.82. The mean was 70. The standard deviation was 3.3. We go in, we paste the command, we hit an enter, and we get back that the 82nd percentile is 73 inches, okay? All right, let's do one more example here where it's not from the left-hand side, okay? By the way, when they give you 2 numbers to trap it between, you put that as your left bound and your right bound, all right? And there's a good set of videos on in the problem sets, and there's also calculator video built into the book, so make sure that you look at all of those, okay? All right, let me see. What was sums to the left? I'm just going to make one up, all right? Just so we can see how to do it, and then we'll be done with what we're doing, all right? Okay, so same with the same distribution, we'll use the normal distribution with mean of 70, standard deviation of 3.3. And let's say that I want to find out what is the cut score so that you have the top 2%. So again, mu is equal to 70 and sigma is equal to 3.3. So in other words, so the top 2% here. Now if I put 2% into the calculator, it's going to think that I wanted the area shaded from down here. It's not going to assume the area up to the right. So what I need to give the calculator, in order for the calculator to be able to understand what I'm asking it, I got to give it this green shaded region here, not the brown stuff, because it always wants it from the left-hand side, okay? So if that's the case, if I want the cut score for the top 2%, then what I'm looking for is what? This lower part down here has got to be what, 98%? So I would go INV norm 0.98 by 70 by 3.3, okay? So that's the only tricky thing about INV norm, is you're going to make sure you always give it the area from the left. So let's go ahead and do that. Let's get the calculator up here for you where you can see it. So second distribution, option number 3, it's going to be 0.98, same mean, same standard deviation. Let's paste that. And about 76.8 inches is going to be the cutoff for the top 2% of male heights. Okay, hopefully this was helpful. If not, give me feedback, positive or negative. I'm always looking for feedback on how I'm doing. Okay, thank you very much, and I'll see you soon.